Welcome back to Algebra 1. We're talking about graphs, and we're going to do something the book calls quick graphs using intercepts. Now, that's not what I call it. I call it the cheater pants method, and I used to not teach it because I thought it confused kids to learn a different way. But now that I'm old, I've got all mellow, and I've decided y'all can learn it. So, it's sort of cheating, but why not? Okay, not really cheating, but I'll explain to you what I mean. Alright, the way that always works to graph things is to get y by itself, make your if-then chart, and then plot your points. And it works whether it's in a linear equation like this or some fancy equation. A hyperbola, eclipse, a parabola. It could be anything weird, but it could... Ellipse. I think I said eclipse. Ellipse. It could be something weird and it would always work. So I wanted the kids to learn the right way. Also, another reason why we like the y equals way is there's a button on your calculator that says y equals. For your calculator to graph it for you, you have to put it in y equals. Another reason for my old point of view. But a lot of times this little cheater pants way does make it easier. The only time you're allowed to use it is if x and y do not have anything weird. They're not in the denominator of a fraction. They don't have exponents on them. They just have to be a regular old x and a regular old y sitting there. Then it makes a straight line and you can do the cheater pants method. Okay, so how does this cheating work? This is how it works. You don't bother solving for y. So if we want to graph this, what we do is we just go ahead and say, what if x equals 0? I know, it's shocking, isn't it? Then you take your finger or something and you say, well, if x is 0, then 0 times 2 is 0, so it goes away. So you cover it up. And then you just solve this part that's left. Why is y not alone? Because it's being multiplied by 3. What's the opposite of multiplied by 3? Divided by 3. What I do to one side, I do to the other. What is 6 divided by 3? It's 2. So if x is 0, y is 2. Got a point right there. Next, you do it this way. You can say, well, what if y is 0? I know it's a little crazy, starting with the y. If y is 0, 0 times 3 is 0, that term goes away. And now I just solve for this one. Why is x not alone? It's being multiplied by 2. What's the opposite? Divide by 2. What I do to one side, I do to the other. 6 divided by 2 is 3. I've got my 2 points. If x is 0, y is 2. If x is 3, y is 0. And I've got my line. Ta-da! Cheater pants. Alright, here's another one. Let's do it again. So we're not going to solve for y. Instead, we're going to say if x is 0, it goes away. And I can solve for y. Why is y not alone? It's being multiplied by 7. What's the opposite? Divide by 7. What I do to one side, I do to the other. 14 divided by 7 is 2. So if x is 0, y is 2. Now we'll do it the other way. What about if y is 0? You write your 0 there. 0 times 7 is 0. It goes away. So now I have to do 3.5 into 14. And that would be with my calculator. I don't know that one off the top of my head. I'm going to cheat and go look in the book. It is, 4. It's 4. But I do that on my calculator and figure it out. Alright, so that would be 14 divided by 3.5 is 4. And now I've got it, so if x is 0, y is 2, put a dot. If x is 4, 1, 2, 3, 4, y is 0, I draw my line. Now, notice these dots are on the y-axis and on the x-axis. On the y-axis and on the x-axis, so they're called intercepts. And that's why this is not officially called the cheater pants method, just by me. But it's called, the real name of it is using intercepts. But it's kind of cheating. All right, now what about if you want to do it with one like this? Well, notice y is by itself here. So we need our if-then chart. So we're not really going to use intercepts, but we kind of can. If x is 0, 0 times 4 is 0, y is 40. We could try something else, but we really don't want to try if x is 1, because it's going to just be 36, and we need to go way somewhere else. So what we want to do is let's go ahead and graph our first thing. Okay, when you have something like y equals 40, you don't want to count 40 squares, so you're going to change your scale. So if x is 0, let's make each of these worth 10, and we'll say that's 40, and there's our dot. Do you see that? Our other one is they tried for their other point -10, so we'll use that one. Okay, if x is -10, -10 times 4 is -40, and -40 plus 40 is 0. So this is actually, this was 10, 20, 30, so one square over here is -10. Those are my 2 points, and there's my line. Now, a couple of things. Lines need to have arrows on the end of them, always, unless you're in geometry and only drawing line segments. Otherwise, you're not really drawing the line, because in theory, these go on for infinity. And it needs to keep going. And if you don't draw I had a college professor that if you did not put those arrowheads on there, it was all wrong. Didn't matter. It was 100% wrong. Also, I want if-then charts on every graph. I want points plotted. I said it. And arrowheads on the axes and on the line. Very important. You have to get these little nitpicky things down. I don't know if you noticed, but some teachers are really picky, especially math teachers, and they will nail you on this. So get in the habit of doing it good from the very beginning. It'll save you some grief. All right, here's another one. This one's a word problem. It says that you are selling tickets, spaghetti dinner tickets, to raise money for the zoo. Your goal is to make $1,500. You need to figure out how much to charge for adult tickets and student tickets. You think about 200 adults will come and 100 students, okay? So I made an equation. 200 times however much the adult tickets cost plus 100 times however much the students cost should equal 1,500. So we're going to make a graph of this equation using cheater pants, okay? So we start by saying if x is 0, chink, it goes away. Now why is y not alone? Because it's being multiplied by 100. What's the opposite? Divide by 100. What you do to one side, you do to the other. So divide both of these, y equals 15. Now we're going to do our other one. What about if y equals 0? It goes away. You cover it up. 200, y is x alone, multiply by 200, do the opposite, divide by 200. What you do to one side, you do to the other. 15 divided by 2 is 7.5. So if this is y, this is x. If x is 0, y is 15. I'm going to say 5, 10, 15. Okay? If x is 7.5, that's 5, that's 10, 7.5 is about here, y is 0. So now we can't have, we're not going to give them money, we can't have negative money. So we really only need this first quadrant. And really this is one situation where we really have a line segment, not a line. So this would be if you had all of your, these are your two situations. All adults or all students. And that's not going to be. So you know in reality what you want is probably something here in the middle. So it looks like this is that's X and that's Y, and X is the adult. It looks like the adult maybe should be about $5, and the student ticket looks like it should be more like $9. That probably wouldn't work. You're probably going to have to switch it up. Let's see what they said. They said that the adults should be 6 and the students 3. They thought that looked like a good point right there. They said that one was the best one, that people don't want to pay more for the student than the adult. All right, so I don't know. There are a lot of math problems that people in reality never do. But, and that might be one of them. I think that people would not do that because it's not going to be all adults or students. I think it's one of those crazy math problems that exist in math world but nowhere else. But that's sort of what makes math fun, is getting to laugh at some of these problems. All right, math is fun. See you next time.